Good morning, students. Chapter 2, Electrostatic Potential and Capacitors. Electrostatic potential. What is potential? Potential energy of point charges, system of charges, dipole, potential energy of dipole. Each and every topic is over. Now, one of the most important topic of electrostatics, that is capacitors and capacitance. First of all, what is capacitor? See, a capacitor is a system of two conductors separated by an insulator. Definition: a capacitor is a system of two conductors separated by an insulator. For example, here we have two conductors, conductor 1 and conductor 2. Okay, and they are separated by insulating medium. You know that vacuum air is insulating medium. Yes or no? Yes, this air is insulating medium. So between them there is insulating medium. Okay. Now see, on first conductor there is charge Q. On second conductor charge -Q. Potential of first conductor is V1. Potential of second conductor is V2. We have the two conductors have charges Q and -Q with potential V1 and V2. So what is potential difference between them? With potential difference, V is equal to V1 minus V2. Clear? Okay. The conductors may be so charged by connecting them with battery. Now you may ask this, how charges are induced on these conductors. Okay. You have to connect battery. For example, if we have two plates, it is connected with battery, positive terminal, negative terminal. So it is positive terminal of battery. So this plate will become positively charged and this plate will become negatively charged. Okay. So these conductors are charged with the help of battery. Now in this case, if we want to bring unit positive charge from conductor 2 to conductor 1, unit positive charge from conductor 2 to 1, due to repulsive force, it may not move with itself. We have to do some work. Then yes, potential difference is work done per unit positive charge in taking a small charge from 2 to 1, and therefore that potential difference is directly proportional to charge. Okay, V is proportional to charge, and for each and every time, every situation, for charge on this conductor, if you find potential difference, they have some charge on conductor, potential difference. Then for each and every case, if you find Q upon V ratio, it will be constant. It will be constant, and that constant value is called capacitance. Again, if you take charge Q is charge on capacitor, it's on both plates. Okay, here it is positive, here it is negative. And if you take potential difference between them, then for each and every situation, if you find Q upon V ratio, it is constant, and that constant is called capacitance. Here the C is called capacitance. The constant C is called the capacitance of capacitor. It is capacitor. And C is equal to Q upon V, capacitance of this system. C is independent of Q or V. It depends on shape, size and separation. That is configuration. That we will prove. Okay. Now, what is SI unit of capacitor? SI unit of capacitor is farad. Okay, and it is denoted by capital F. And what is capital F? It is coulomb per volt. From this equation, coulomb per volt. Okay, if you are given fixed capacitance, capacitor having fixed capacitance, then it is its circuit symbol. It is its circuit symbol. Two parallel plates. Okay, and if you are given capacitor having variable capacitance, then it is circuit symbol for variable capacitance. Clear? Again, what is capacitor? System of two conductors separated by insulating medium. And for this system, Q upon V ratio is constant, and it is called capacitance. C is equal to Q upon V. Q, charge of capacitor. V, potential difference between two conductors. V is potential difference between two conductors. Okay, now see, As C is equal to Q upon V, capacitor with large capacitance, if value of C is more, it can hold a large amount of charge with relative value of V very small. Okay, see, C is equal to Q upon V. If we have value of V very small, okay, and its capacitance is high, then we can also store charge on it high. See, basically capacitor is used to store charge. See, at lower potential, if we have high potential between two conductors, see in this figure here, if V1 minus V2 is equal to V, potential difference between these two conductors is high, means in this region if potential difference is high, then due to high potential difference, electric field produced is strong. And due to strong electric field, this air is ionized. Just we know that air is insulating medium. But if potential difference between two conductors increases, electric field becomes strong, and that electric field ionizes the air. And if air is ionized, then these charges can be accelerated. Means charges can move from one conductor to another conductor. And we know that if negative charge move from conductor to conductor 1, it will neutralize it. Means in short, charge is leaked. So we cannot store charge. Okay, so here we have to keep value of potential difference up to some limit, value of electric field up to some limit, such that insulating property of this medium does not destroy. Clear? So how to write? See, high potential difference implies strong electric field around conductors. Strong electric field can ionize surrounding air and accelerate the charges to opposite plates, thereby neutralizing the charge of capacitor. Means charge of capacitor leaks away. We cannot store more charge. Okay, and the maximum electric field that a dielectric medium can withstand without breakdown is called its dielectric strength. What is dielectric strength? Dielectric strength is value of electric field up to which insulator or dielectric can maintain its insulating property. If electric field increases from that value, then its insulating property is destroyed and charge is leaked. For example, for air, dielectric strength is equal to 3 into 10 raised to 6 volt per meter. So if in this case, potential difference between these two conductors is very large, so electric field in this region, if increases from 3 into 10 raised to 6 volt per meter, if value of electric field is more than 3 into 10 raised to 6 volt per meter, then insulating property of air is destroyed. These charges move from conductor 1 to conductor 2 and total charge becomes 0. We cannot store charge on two conductors. Clear? So this point is important. Capacitor is system of two conductors separated by insulator. Medium between them must be insulator. Clear? So it is about capacitor and capacitance basic. Now there are types of capacitors, but in our textbook we will study only one capacitor in NCERT textbook, that is parallel plate capacitor. So what is parallel plate capacitor? What is its equation of capacitance? We will study in next lecture. See. Okay, in NCERT syllabus, we have to study what is parallel plate capacitor. See, easy to understand. Parallel plate capacitor. What is capacitor? Two conductors separated by insulating medium. Here, as two conductors, we have to consider two parallel plates. Two parallel plates. See in figure, we have two parallel plates. One positively charged, one negatively charged. Medium between them is vacuum, distance between them is d, charge on this plate is q, charge on this plate is minus q, cross sectional area of plate is a. You have to remember each and everything. Okay, again, a parallel plate capacitor consists of two plane parallel conducting plates separated by a small distance d, separated by a small distance d. Medium between them is vacuum. A is area of each plate. D is separation between plates. Two plates have charge Q and minus Q. So what is the surface charge density? Surface charge density is sigma. And we know that how to define surface charge density. Surface charge density sigma is equal to Q upon A. For this plate, positive. And for this plate, it is negative. For this plate, it is negative. Clear? Now, see, we have one positive plate and one negative plate. First of all, we will find electric field in three regions. First, second, and third. We already know this case from chapter number 1. See, here, again, we will revise it. In this first region, if I am taking one point here, then at this point, electric field is due to, yes, due to positive plate away, due to negative plate towards, so this E1 due to positive charge, positive plate, E2 due to negative plate, they are in opposite direction. So in outer region 1, resultant electric field E is equal to E1 minus E2 is equal to sigma upon 2 epsilon 0 minus sigma upon 2 epsilon 0. Your answer is 0. Your answer is 0. Yes, in this region, we know in this region electric field is 0. What about this region? Similar. See, at this point, electric field due to this positive charge E1 in this direction, electric field due to this negative charge E2 in this direction. They both are in opposite direction. So outer region 2 electric field is equal to E1 minus E2 is equal to sigma upon 2 epsilon 0 minus sigma upon 2 epsilon 0. Your answer is 0. E is equal to 0. Okay. Now between two plates means in this region. In this region. What about electric field? Yes, if you take a point between two plates, then due to positive plate it is away. Due to this negative plate it is towards. They both are in same direction, so you have to write plus. So E is equal to E1 plus E2. Sigma upon 2 epsilon 0 plus sigma upon 2 epsilon 0 is equal to T sigma upon 2 epsilon 0 means sigma upon epsilon 0. We know that between two plates, here resultant electric field E is equal to sigma upon epsilon 0 and it is from positive plate towards negative plate. From positive plate towards negative plate. See, here surface charge density is sigma and here is minus sigma. So you may ask, sir, why you are not putting minus sigma sign? Because this minus sign indicates charge on plate is negative and we have already considered its direction. Okay, so sigma upon 2 epsilon 0, sigma upon 2 epsilon 0, it is magnitude. It is magnitude. Okay, now E is equal to sigma upon epsilon 0. We know that sigma is equal to Q upon A. So sigma is equal to Q upon A. So what is value of electric field? E is equal to Q upon A epsilon 0. Now, here, see this statement. A parallel plate capacitor consists of two parallel conducting plates separated by a small distance d. Distance between these two plates d is smaller than area. D is smaller than area. So electric field between two plates sigma upon epsilon 0 at each and every point is uniform. Is uniform. Okay, between any points on it is electric field is uniform. Okay, now for this uniform electric field, potential difference between two plates V is equal to ED. Again, this equation, see, if you remember, E is equal to V upon T. Then V is equal to it is E. Then V is equal to it is E. So you have to remember this equation. V is equal to E. Put value of E, that is Q upon A epsilon 0. Now make Q upon V as subject. Q here is V in denominator, A epsilon 0 on opposite side, T is also on opposite side. So Q upon V is equal to epsilon 0 A upon T. And we know that Q upon V is called capacitance. So C is equal to epsilon 0 A upon D. C is equal to epsilon 0 A upon D. Now remember that statement. C depends on shape, size and separation. Yes, epsilon 0, medium between two plates. A, size of conductor, and D, separation between two conductors. So here value of C depends on epsilon 0, means medium between two conductors. Here we have vacuum between two conductors, so we have used epsilon 0. For vacuum we have used epsilon 0, A upon D. So it is equation of parallel plate capacitor. When medium between two plates is vacuum. Now if medium between two plates is replaced by some another medium, see here, same two plates with same charge, with same separation, only medium is changed, another dielectric medium. Then what is its capacitance? See this? Yes, if another insulating medium is placed, you have to write epsilon. Then C dash is equal to epsilon A upon D. We know that epsilon R is equal to K, that is dielectric constant. Relative permittivity, K, dielectric constant, epsilon upon epsilon 0. So epsilon is equal to epsilon 0 K. Put here value, epsilon 0 A upon D is already C, then C dash is equal to Ck. C dash is equal to Ck. Yes, we have obtained one equation of force. Fm is equal to F upon K. Similar relation, C dash is equal to Ck. So when it is vacuum, you have to put epsilon 0. When it is another medium, you have to write epsilon. Clear? So it is all about parallel plate capacitor. Now in next lecture, we will study series and parallel connection of parallel plate capacitors. Like you know, series and parallel connection of resistors. Pause your video, write down from board, make notes and send notes on WhatsApp number given in your group. Thank you.